September energy consumption levels of a single-family home are found to be normally distributed with a mean of 1,050 kilowatts and a standard deviation of 218 kilowatts. For a randomly selected home, find the probability that the September energy consumption level is between 1,100 and 1,000 kilowatts and 1,225 kilowatts. Round your answer to 4 decimal places. Okay, and these are our answers possible. Now remember, you might have a rounding error, so let's see what we get. All right, so the pieces of information we know is we know that X bar is going to be 1,050. We know the standard deviation is 218. Those are 2 pieces of information. One of the other things we know is that we're looking for between, right? We're looking for the probability. So you're looking for the probability between 1,100 and, so the random variable X, meaning the consumption level, is between 1,225. Now, in this case, we need to find, basically, if you were to make a distribution like this, it's not very good. X bar is the mean, and that would be the 10,050. And we are now trying to find the area between 1,100 and 1,225. That is this area right here. Okay, how do we find that area? We need to find z-scores. We need to find the z-score that corresponds to this. So the z-score for that is going to be z equals 1,100 minus 1,050 divided by 218. This is going to give you an answer of 0.22935. You can use 0.22 or 0.23. I used 0.23 when I first did it because it was 0.9, so it made more sense to round that up. And z-scores are only in 2 decimal places anyways. Now the next z-score we need is this one right here. And so the z-score corresponding to that is going to be 1,225 minus the value basically you're testing is this value, minus the sample mean, 1050, over the sample standard deviation. And that's going to give you your z-score. And that'll give you 0.802. And again, we'll just use these 2 numbers and these 2. I don't have my table in front of me right now for how to find these, and that might be something I should do. I will maybe post another video about how to find z-scores in case you are a little nervous about how to find them. But basically, in the back of your textbook or in the appendix, you'll have basically a table that says z-scores. And this part right here is going to be the 0 point, for example, if we wanted to tackle this one, the 0.2 would be here. And then if I use this number again, then the 0.00 is here, 0.01, 0.002, 0.03, and I would use this, and then I would go over, and then this will be the corresponding z-score to 0.23. And now remember, z-scores basically, so when we get this, to show you this, the z-score that corresponds to that, so why don't you check to see whether you get that number, and that's a great test. You should get, 0.23 is the z-score. That means you're kind of finding this area right here. And in this case, you should get 0.5910. Okay? And now the other one we need to find is the z-score for this 1,225. So, geez. My writing is not very good, so that's why I'm saying these side comments. This will be basically the 0.8 mark, which means you would think that this should be more area shaded, and it is. It's 0.7881. Okay, this right here and this right here, those are z-scores. These are probability areas. That's basically what's underneath the curve. Now, in order to find this right here, we just need to subtract these two. And so you just subtract 0.7881 from 0.5910, and you end up getting 1,971, which, yes, is not any of these answers, but which one is the closest to? C. Okay, so that is actually the answer to this problem. All right, if you have any more questions, feel free to email me. I'll be happy to drop anything like this. So, thanks much.